Okay, sorry about how long that last video was. Also, sorry that I mentioned that there was going to be a sub talking about that last information. I've probably already apologized to you for that because I will do that on Monday and Tuesday. Anyway, this is the first one about volumes. It's going to be shorter. It's of the same objects that we talked about last time on the surface area one, but now it's about volume. So volume is a new concept. Volume is the measurement of the amount of space on the inside of something, which you've probably been told before, so that's probably not anything new. But now, since we've kind of got three dimensions that we're worried about, there's going to be three things that get multiplied. So I'm sure you're used to length times width times height. Whoops. Length times width times height for things. I can't not draw. That's really dumb. So when they say things like area of base times height, that means area of base just like you're used to from surface area, but area of base in a cylinder is already, of course, length times width. So we've now got really three things that are being multiplied, and we're talking about cubic units, all of that kind of thing that you're probably used to hearing again. The measurement of the space inside is measured in little tiny cubes, as if we were trying to fill it up with those. So again, this is hopefully not new. So prisms and cylinders have this volume formula, area of base times height. If it's a cylinder, of course, the area of that base is going to be pi r squared. But it's like thinking about this like a stack of Post-its. You've got the area of the one on the bottom, and you're multiplying that through by the height, and that's how we're going to kind of fill up that box or that space with volume. It doesn't matter if it's leaning over. It's still this kind of vertical height that we would have for that stack of Post-its. I'm actually looking at a stack of Post-its in front of me right now. And if you could lean them over, or like a stack of coins, you could lean them over on one on top of another, slightly off center, I suppose, and it would have the same volume. That would change the surface area. The area of these faces is no longer the same as the area of those faces, but volume is your friend. Volume is a whole lot easier to deal with than surface area. Okay, here's this really cool demonstration about how we're going to find the volume of a pyramid. I actually have a cutout version, or sorry, a 3D printed version of this in my classroom. I will show you because you kind of have to hold it and turn it around and that kind of stuff. But you can actually slice a prism, and I know how to do it with triangular prisms. It's pretty cool. Again, that's the one I have modeled in my classroom. I can also show you with a cube. I don't have a model of it, but it's not too hard to kind of explain that. You can actually slice up these things and get pyramids that you can show are the same volume. So the punchline on all of that is that you can slice these prisms into three three prisms that you can see have equal volume. So the volume of a pyramid or cone turns out to be 1/3 of the prism kind of that it occupies. So if you could imagine a prism having the same base and same height, you just divide by 3 and you find the area of that pyramid. Okay, so that's it for that page. So there we go. And cone would be the same thing, but of course, area of the base on a cone is just pi r squared because that's the area of the circular base. So again, I think this is way easier than surface area. Here's all the stuff in one place in this little table, where we've got base times height, 1/3 times base times height, slightly simplified a little bit for round things, but it's just base times height or 1/3 times the base times height. Notice they're using capital B for all these bases. The reason they're doing that, and notice how they didn't do it for things like trapezoids or parallelograms or anything, because this base, when we're talking about, and we did this, I don't know if I said this enough, I feel like I didn't say this enough in the surface area video. They're using capital B there because that capital B is already the result of an area formula. So that's already got two variables in it, and it's already kind of a two-dimensional idea, so they're using capital B for that kind of base. It's unfortunate that we use the same word base to talk about area of a base as the same as, like, here's a trapezoid. This thing is called a base, and this thing is called a base, but those are segments. Here, this base is a pentagon, and it's a two-dimensional object, and that base is in area. These bases are in linear units, so that's why they use capital versus lowercase. Okay, let's do some examples. All right, I don't want to do all these. Let's see which ones are good. Oh, let's do this one because it may be hard to identify what is the base and that kind of thing on this thing. So this thing is a triangular prism. If you didn't know, this is, and we're talking prism because these are the two congruent parallel faces. So each one of those is what we're going to identify as the base, and the distance between them is what we identify as the height. So, okay, here's the formula in variables. Volume equals, and I know it's pointy, but it's actually a prism. It's not a pyramid. base times height. Well, base here, that base I'm going to write as half times base times height. Oh gosh, look at this. Now we have two heights. This is because it's a triangle. I'm going to use the area of a triangle formula for that part. Area of a triangle. So be careful. There's triangle height and there's prism height. They're both h, but they are different. This is height of the triangle. This is height of the prism. Okay, so I like how my pencil gets thinner in this case. Okay, so what's nice about having in this version is this kind of gives me a list of ingredients that I'm going to need. So for the triangle, I need the base and the height of the triangle, and I don't have all that. I have this 5 and I have this 13. Well, with Pythagorean theorem, I can figure out that that's 12. So this is 1/2 times 12 times 5 times, now this height that I'm talking about is height of the prism, and height of the prism is 9. Area of the triangle is then 30, and 30 times 9 is 270. And this is cubic units. Okay, I'll do this one in class. Let's just highlight that for now. But it's going to be area of the base times the height. Is that it for that page? Oh, we're cooking. All right, find the volume of the... Okay, this one's weird. This one's weird because it's not a regular pyramid. This thing would be a monster to try to find the surface area of, because this is not a square. Whoops, I'm trying to shade that. This is not a square on the bottom. It's a rectangle. And so... yeah, they should tell you it's a right rectangular pyramid. I mean, what else would it be? Actually, no, for volume, they don't even have to tell you that. But if they told you it was a right rectangular pyramid, you could try to find the surface area, but you couldn't use the regular formula, the surface area formula you're used to, because these 4 triangles on the lateral faces are not congruent. They don't have the same slant height. Like, it's a weird one because it's a rectangular base. So look out for level 4 possibilities on rectangular based pyramids on surface area. Anyway, we're here to do volume. Volume formula I'm going to use again. Careful now. It's 1/3 times base times height. What is that base formula? Well, it's just length times width. And height is height of the pyramid. 1/3 on the bottom here, we have a 4x8 rectangle. And the height is, oh, I don't know the height. The height is this thing right here. And so, and I have this triangle here that's a right triangle. That's going to be helpful. I'm going to draw that separately so I can kind of get in there and see what's going on. All I know is that that's 11. Can I find this down here? Well, I think so. This is a rectangle down here in the base. And that, so I guess I did need to know it was a right rectangle, because I need to imagine that's at the center. So if you can imagine that rectangular base, this is a 4x8 rectangle, and that's the point, that's the foot of the altitude I need. And the triangle that I'm talking about right here, this little side right here is kind of like this dotted line here. That would be 4, because it's half the length of that rectangle. And now I can find this using Pythagorean theorem. Bam. And so that is the square root of 105 over here. So that, there we go, square root of 105. Square root of 105 times, oh, what is that? 32 divided by 3 times the square root of 105. I'm just going to write it this way. There's my exact answer. Composite solid. Okay, let's do this in class. This one isn't too bad. Wow, that's a really short video. I kind of owed you that. All right, I'll see you in class.